Alright, in this video, we're going to go ahead and take a look at exponential forms, and we're really going to look at writing exponential forms from like a scenario and things like that, looking at the arithmetic behind it, the strategies, and everything that just goes along with it. Okay, so we're looking at, by the end of the lesson, we're going to be able to, and some of you guys probably know this already, but just to keep everybody on the same path, we're going to be going over it. How am I going to find percentages of given amounts, and then given a scenario, which I was just talking about, how do I produce an exponential function and make it to use it to make predictions, rather. Okay, so some of the things that we're going to talk about is kind of like if you think about it, like maybe a magazine subscription or something that, or an event. And so we're going to deal with annually, quarterly, and monthly. So basically, if we look at the length of 1 year, like say your birthday, right? That happens once a year. Okay, so annually just means per year you're going to get one of those events. And then if you think of summer, winter, fall, and oh gosh, what's the last one? Spring. We're going to go ahead and take a look at every 3 months. Those are going to occur. So we got a season change every 3 months. And then just like a monthly thing, maybe your favorite magazine, or maybe some free video games that come out with your monthly subscription, like that's going to happen 12 times a year, right? And so being able to chunk those up and apply them to the correct scenario is going to be super important. Okay, so let's go ahead and take a look at just finding some percentages real quick. And this guy right here is going to be a big deal to start us off with things. Okay, so say you get your one of your first jobs and you're doing really well and you get a raise. Okay, so say for example, and I'm doing this part right here, is that say that you get a 12% raise, and then you get your new paycheck and it's $550. What is going to be the amount of your old paycheck? And so the way that we're going to look at this is that let's start to put the things together real nicely. Okay, first of all, we got ourselves a raise here, so we know that that is going to the amount that we're going to find has to be lower than $550, okay, because you got a 12% raise. 12% right here, we have to remember that we are going to be using decimals, and when we do decimals, we have to be able to convert back and forth between the percentage that is given. So say if you have 12%, we go ahead and we skip this 2 places to the left, and we have ourselves 0.12 as far as the decimal goes. All right, and that is going to be a rate. Okay, so for our new paycheck, the new amount, which is going to be right here, okay, and that is going to be the new amount, which is $540. And we want to find out what was our paycheck before we got that raise, okay? And so we don't know, we're going to just call it X, as we typically do, and that is the old amount. And you can see that we are going to be using the formula, dropping this in over here, okay, that guy, and then we're going to be dropping the blue stuff in over there, and then finally the variable goes there, okay, that guy, and so and the 1 always stays. So let's get this set up and then solve it. Okay, so we dropped everything in, and I'm just going to simplify this guy right here, adding them up. And now we just have to do some crisscrossing. Okay, so let's solve this out. Just using cross multiplying. So 540 times 1, hey, it's just 540. Okay, and then we got x times 1.1 2, which is going to be 1.12x. And then we are going to divide each side by 1.12, like that. So those go out. And so finally, x, which is going to be our old paycheck amount, is going to be, after I'm dividing each side of 540 by 1.12. Okay, so I'm getting this right off my calculator here, and that's going to be $482. Now, I'm getting a decimal that is going to look like this, all right? But since we're talking about money, we only want to go out to where cents would be. We don't want to go on beyond that. And so we got, rounding correctly, we got this is your old paycheck, okay? So it looks like you got a pretty good raise there. Not too bad. And so you're going to be bringing home almost $60 extra a month or whenever the paycheck was, okay? So that said, let's go ahead and do the same thing down below. So say you had to receive a decrease in your paycheck of 34%. Yikes. That might be time to find a new job, but say maybe you can't do that right at this point. Let's find out what your new paycheck would be. Okay, so if we are going to get a decrease, okay, of 34%, unfortunately, we're going to have to put a negative sign in front of it, okay? So a decrease of 34%. We're going to go ahead and make that decimal skip 2 places to the left. Oops, and we're going to get a negative 0.34. Boo, and that is going to be our rate, okay? And says your new paycheck after the decrease, okay? So after the decrease is, so we have this business of new, which is going to be I'm keeping the colors the same, so $1,024. That is the new paycheck. And what is the amount of the old one? Okay, so the old one is going to be X, right? We don't know what that is. We want to find out what that old higher paycheck is going to go ahead and be. And the reason why I say that higher or lower, you want to make sure that you think about, okay, in this one, it was going to be the old paycheck was going to be lower than this amount because we have we got a pay increase, okay? So we went from this to this. So now we went ahead and we're going to have something that's going to be higher because we decreased 34% from some old paycheck or some old amount that we made. So let's plug it in and see where that takes us. Okay, so got everything all plugged in here, and I'm going to settle up this guy right here by subtracting it. Okay, so that we have 0.66, and let's do our cross multiplication again. So 1 times 1024 is just that. So I got 0.66x. And then we're going to divide each side by 0.66, and we're going to see how much did we used to make. And so after hitting the calculator here, it looks like, okay, so it looks like we made $1,551.52. Now, the reason why I say 52 is because we went ahead and we got, hold on a second, I have a dog that just jumped up by me. We have this showing on the calculator, but again, we want to round to the nearest cent, and so at the end of the day, we get this amount, and that's how much we used to make. Sad face, back in the good old days, for whatever reason, okay? All right, so that's a skill that we're going to need going forward, and we're going to take a look at building some of these functions, some exponential stuff. You might probably remember from Math 1, and let's see where this takes us. So I'll see you in the next part. All right, so for this first example, real quick, I want to make sure this is supposed to be a 40% increase. Before we get down to that, I must have been watching some Star Wars and hit a wrong button somewhere, so who knows. But anyhow, let's take a look at what we are tasked with. we're given a city's population has increased 40% during the last 5 years and is now at that amount of people, okay? So what I like to do is that I like to fill in what we know first, okay? And I like this little organizer that I always kind of draw for myself. And I know that I don't know the city's old amount of people, whatever they, not old people in there, but the people that originally were in the city 5 years ago. So we're going to call that X, okay? Because we just know how many people are in the city now, which is this amount, okay? Now we know that the rate was a 40% increase over 5 years. Okay, and so this usually makes this kind of sets the stage for what I'm going to go ahead and be able to the process here, because and you'll see why this makes sense in a moment. So the first thing that we are tasked with is, it says, what was the population 5 years ago? So population 5 years ago, let's call on what we just learned in the prerequisite skills here, the formula that looks like this. Okay, so I know the new amount, I know the old amount, and it doesn't account for the number of years. We're going to take a look at that later, but we know that that's a 40% increase, okay? So let's fill it on in. And so we know the new amount was the people that are in the city now, and the old amount is what we're trying to find, because that's what it asks us from the 5 years ago. We had a 40% increase, so that's 1 plus 0.40, and it's always over 1. I'm going to clean up that top real quick. So 1 plus 0.4 is just going to give us 1.4. Okay. And now we cross multiply, and we have to do this basically the same thing. So knocking this down, oops, writing the wrong thing, then erasing it, and now we're okay. And I'm going to divide each side by 1.4 to get it away from 1.40 to get away from that x, and so that's going to give me. Okay, so it looks like the amount of people are going to be this much. So in 5 years, we got some. So there is that many people. So in 5 years, it looks like they gained quite a bit, right? And so we're going to check that off our list. That is the first part. Now, here we go. This is where things that we're going to have to break out some newer stuff. So let's read this on over. It says, assuming that the population increased at the same rate each year. That means is that it's not going to go ahead and have this big, boom of people that came to the city one year and then, people left the city the next year, et cetera, et cetera. What was the annual rate of increase? So this is what we do. Looking at this part, okay, this new equation right here is that this guy is going to be part of a similar or part of an equation that we built a lot in Math 1. But from this point, let's go ahead and start doing some stuff out. We know what R is, okay? And R is going to be this business of the rate that went up 40%, okay? And so R is going to be this 0. This guy. Now, this is where the first part that I had showed you is going to matter, okay? That 40% is over 5 years, okay? So since it's over 5 years, and we want to know what the yearly, so I'm going to try and break this up into 5 the best I can. That's not too bad. Is that we just want to know this amount. And we can't divide that by 5 because it's just not going to work out that way exponentially. So the way that we set this up is that we have one whole chunk, okay? So this whole chunk right here is like one time period. This is going to be 1/5 of the time period. So therefore, if we want to know, putting all the pieces together, if we want to know what the percent is going to be increase per year, is that we go 1 plus, and then the 0.4, and we raise that to the 1/5 power. Okay? And that's a point, 1 plus 0.40, and we raise it to the 1/5 power, because that time period is, we want to know what 1 year is out of the 5. So that said, is that we are going to have to use the calculator for that. Okay, so after we punch this into our calculator, we're going to get this, and we're going to get 1 point, and I'm going to take this out a little bit, 6,961. So I take it out a lot of decimals, and we're still not done quite yet. What we want to do is this, is that notice, okay, and this is what a lot of students forget to do, is that we think about, okay, well, the rate for 5 years was this guy right here. That's what the R was, okay? Rate for 5 years, 40% increase. Now, inside of here, we added a 1 to that rate. What we want to do to get the rate for 1 year out of 5 is to subtract that 1 out of there. So when we subtract the 1 out of there, we're going to go ahead and get 0. So basically that one's going to be gone. 0.06961, and then we want to turn that into a decimal, okay? Because it's asking us now for an answer. What is the rate that is going to go ahead and be per year, assuming the rate was increasing every year the same? So we this time take the decimal place and we go 2 places to the right, and that is going to give us this amount, and I'm going to take it out to the nearest hundredth. I get 6.96%. Ooh, I'm smashed in there, okay? So increase per year, okay? Not just 5 years, per year, okay? And so that is going to be the answer to the second part here. So let me go ahead and put these answers where they should be over here. Okay, so there we go. And so now it is telling us to do the following. It is, now that we have this information, it says write an equation that models a scenario above on a yearly basis, okay? So that means is that when I go ahead and I want to make basically an equation that for no matter how many years, okay, that are going to go ahead and pass from this particular year that we started off with, okay, which is going to be this old amount over here, I can make predictions from this because I'm building a formula. So we're going to get y equals, okay, and A is going to be the starting amount. So since A is the starting amount per year, that's where we are, our old amount, the amount in which we started measuring from, that is going to be this guy right here, okay? So we started with this amount. And how much did we gain per year? Okay, this is per year, that much. So we need the decimal version of that. So we're going to skip the decimal places 2 places to the left, and we're going to get that 0.0696. Okay, I suppose that much. And raising it just to the t power. So putting things together, I get y equals this much right here. 1 plus, oops, I'm not going to use the plus sign, that'd be silly. And I'm going to just probably, let's see, round it to 0.07, because this is going to round that guy up, okay? and to the t. So there we go. That is the equation in which we're going to go ahead and use to predict any year from the starting amount of that would be this, whatever it was 5 years ago, okay, which we know it's going to be this guy, and whatever year that we drop in for t, we're going to be able to find the amount of people that we're going to be in the city's population. Okay, so that's how we do our first one, that type of scenario, and I'll go ahead and I'll meet you in the second example. Okay, in this example, we got something that's a little bit similar, and it has to do with a financial magazine. And the magazine had, let's go ahead and take a look. It had 57,500 subscribers, okay, on January 1st, 2010, okay, which represented an increase, okay, so we got an increase of 243% in the 10 years since January 1st, 2000, okay? So let's take a look at how to fill in our little graphic organizer here, okay? So it says a financial magazine had this much in 2010, okay? So 2010 right here is going to go ahead and, of course, be larger than the year 2000. So what we're going to look at is that it looks like the new amount, okay, that is going to be in the year 2010, and the old amount, which is in the year 2000, we are going to have right now 57,500 subscribers, okay? And we don't know, it doesn't look like we know the old amount, okay? Now, the rate is going to be 243%. Wow, that's a lot. And that is over 10 years, okay? And so what we're looking at is kind of the same thing, is that we want to find out what this old amount is, okay? And we want to start plugging it in the same way that we did in the first example, these guys. Now, in this example, we're going to use the final equation to make some predictions about how many subscribers were in any particular year. So let's take a look at setting this thing up in the first part. Okay, so we have our trusty formula here, and that is going to tell us what we need to know to build the equation. So let's go ahead and say the new amount, which is going to be 57,500 subscribers. And we don't know how many subscribers we started off with. We do know that there was a 243% increase, so we're going to have to take that 243 real quick percent and change it into a decimal, skipping that decimal place 2 places to the right, and I get 2.43 and then all over 1. Cleaning up that top is going to give me 3.43%, okay? And again, it's an increase, so I'm adding it on there. So, you know, it's not going down whatsoever. So I'm adding the 2.43 to the 1. All right. So now we do our cross multiplication like this. And I'm going to put this down below because I wrote big and then erase it out later. So that's going to give me 1 times 57,500 equals 3.43x, divide by 3.43 on both sides. Okay, and we're going to get this amount. Now, this is x equals, and this is where we are going to use kind of like our common sense in mathematics here. Is that since that these represent subscribers, we can't have a partial subscriber, okay? Or, you know, saying that it's just a regular, it's a count of people. And so therefore, what we're going to do is that since that wouldn't represent a whole person, we're going to get rid of that that percentile there, because having this much of a percent of a person doesn't make sense. And so what we're going to do is that we're going to say, well, how much is what was the old amount, okay? And the beginning amount that we started off with, our old amount rather, is going to be, and I'm going to just put it right in the box for ease of instruction here, is going to go ahead and be that much, okay? So, we started off 10 years ago with 16,763 subscribers, and 10 years later, we ballooned up to 57,500. Okay, so let's go ahead and now, since we have the percent and we have all this information, let's start to tackle the second part. Okay, so from this one right here, it says yearly rate. It mentioned the scenario that there's a 243% increase over 10 years. We want to find the percent increase over 1 year. So again, much like in the first example that we did, we have this over 10 years. Okay, and if we break it all up, that 10-year chunk, we want the increase over 1 year. So much like we did in the first example, we just want this piece right here, okay? And so that is going to give us 1/10 of the time, all right? And so filling things in, we know that the time in which we're going to want to figure out is going to be 1/10. And the rate, okay, is going to be, we got to have it in decimal form, 2.43. So plugging everything in, we're going to get 1 plus 2.43 raised to the 1/10 power. And that's going to give us this guy right here, okay? Okay. And so we know that we want to find the rate, okay, just the rate. So we know that we had added in that 1 originally, so we want to subtract that 1 out, and we're going to get this right here, and skip the decimal 2 places to the right, and that is going to give us 13.12%. So we know that we have a 13.12% per year increase, okay? So increase in subscribers per year. That's really good. Okay, so now we're going to take that information and we're going to build the equation. So let's go ahead and find everything. A is an old amount, okay? The time, okay, the time we're going to go ahead and just leave blank, okay? We just leave it as time, okay? Just as when we left it in this form before, okay? As we just left the equation, because that is going to be our input. So t is just going to be time, and that's it. And then the rate is going to be something that we just found, which is going to be this guy right here, but in the decimal form, okay? So let's drop everything in and see where this takes us. We get y equals the amount of subscribers we started off with, which is 16,763, 1 plus, and I'm just going to go and got that guy, and we raise it to the t power, and then we clean it on up. I'm just going to go ahead and add this part right here. Okay, and that is our equation that we're going to go ahead and use to answer the last part. Okay, so let's go ahead and box all the good stuff that we know that we found. Okay, these are the things that we found. Again, starting amount, increase per year, and then we found an equation. Now, what we're going to go ahead and do is that we think about the question and what it's asking us. Okay, is that how many subscribers that they're going to have on this date. Okay, so what we're looking at is that we take our equation that we went ahead, or a function that we just went ahead and built, and we're going to take a look at, well, what is t? What is the time from when we started counting? And the original amount that we started counting, again, was in year 2000, right? Year 2000. So if I'm looking at how many did we have in 2004, then t is going to equal 4 in this case, okay? It's going to be 4 years from the year 2000, okay? So therefore, I go y equals 16, 7, 3, da-da-da-da-da. Put this in here, like that, and let t equal 4, and let our calculator do the work here. Okay, so for our calculator, we got this right here, 27,447.913 and some change. But we're not going to worry about that because we can't have 0.9 of a customer here, and unless they're like a zombie or something. And so we would have 27,447 subscribers in 2004, or January 1st, 2004. Okay, and that's how we use the equation that we went ahead and made. All right, and so any amount of years in the last part that from the year that we started counting, whatever that happens to be, is just going to go ahead and be put right there. If I wanted to know how many customers I was going to have in 2040, I could have just let that equal 40, okay, and put it in my calculator. So that's one of the uses of writing an equation, because it allows us to make predictions and find out some past information that we couldn't do just using this original scenario here. Okay, so let's go ahead and I'll meet you in the final example here and see where that takes us. Okay, in this part, we're definitely going to go ahead and put all the pieces together, and it looks like we are looking at a new car. So let's go ahead and take a look. It says Sanjia, she paid looks like $20,000 for a new car in April 2004. Okay, and then the car was worth $6,000 in April 2012. Okay, so let's start to go ahead and fill in some of the things first before we even start tackling all the questions down below. So the old amount that she paid, now remember, is that new doesn't mean like the new amount all the time for a new car. Okay, it was new in 2004. Okay, and then we are looking at going on over to 2012. Okay, those amounts. And so we have the old amount was $20,000. Okay. And the amount that it is worth in April 2012 is $6,000. Okay, so let's also fill in some of the information that we need. Is that it looks like it took 8 years, right, to go from 2004 to 2012, and the rate we don't know. Okay, so we're just going to go ahead and call that guy X. So let's go ahead and see the way that we're going to use this information to tackle the rest of this particular problem, because it's a little bit different, and then we add some stuff at the very end in which we're going to go ahead and use the final build of this function to make some predictions. So let's go ahead and take a look. Okay, so we're going to start with our trusty formula here, and we need to go ahead and we want to find the how much it decreased over the 8 years. Okay, so let's just go ahead and take a look at that. We got new over old equals 1 plus r over 1, so we want to know what the rate is going to go ahead and be over those 8 years. Okay, so let's fill it on in. Okay, we got this guy, and now doing some... Okay, so we got this set up, and in this case, we don't really need to do any crisscrossing because we're just trying to solve for r. We could if we wanted, but if you remember this, where the zeros are all going to cancel out, so we end up with 6 over 20, which is going to reduce down to 3 over 10 on that side. So we got 3 over 10, which in decimals is going to be 3 tenths. Okay, of course. So we look at this like that, equals 1 plus r, and then we subtract 1 from each side. So I subtract 1 and subtract 1, and that is going to go ahead and give me, at the end of the day, r equals a negative 0.70. Okay, so that is going to translate into, unfortunately, a 70% decrease over the 8 years. And as much as I hate to go ahead and say it, that's usually the way that cars go. Okay, they decrease quite a bit. Okay, so that is over the 8 years here. Oops, I put decrease twice. Let me go ahead. So over 8 years. And let's go ahead and start to put all of this together so we can evaluate the next part. Okay, so let's read this. It says the yearly rate says the rate mentioned in the scenario shows a 70% decrease. Okay, that's important because we have to definitely take that into consideration when we're plugging into the next part, that it's a decrease. Okay, so we want to find the percent, not increase, decrease, that's a typo there, over 1 year. So to do so, let's take a look. So I get 1. Now, right here, the rate is going to be negative. Okay, so we have to put a negative 0.70. Okay, and over 8 years, we want to find 1 year. So going back to what I have done in the other videos, so let me get this in 8 parts. Okay, so there's the 8 parts. So that 70% decrease was over the 8 years. And again, we just want 1 year, okay? So that's like 1/8 of the time. And so that's what we want to let the time equal. Oops. Over here, 1/8. And then, after putting this in the calculator, we're going to get that the rate of decrease for 1 year is going to be this much right there. But just like in the other problems, we got to, since we have a 1 in here, we got to subtract that 1 out of there, and that is going to give us this amount right here, which is going to be a negative 0.1397. And so at the end of the day, we are going to get this. We're going to get a negative, skipping the decimal places, 2 places to the right, a negative 13.97%, okay, which is going to basically be that decrease over, percent decrease over 1 year. Okay, so over 1 year, just answering the question over here on the left-hand side is that per year, the car goes down 13.97% decrease. And you could leave it as a negative, or you could just put decrease after it. But you can't just put 13.97 simply because you have to say it's gonna, it has to have a negative in front of it or the decrease after it. Okay, so let's go ahead and build the equation down below, and then we're going to use it to make some predictions. So once we build the equation, we're going to get y equals the amount that we when we started counting, which is going to be 20,000. And then I got 1, and now I have this amount right here, right? The negative 0.1397. And I have that t right there, and that is going to represent the number of years from 2004, so we can use it to answer those questions right there. So let's clean up the parentheses there. Okay, so I just subtracted that out. this part right here and got this part, and that is going to be the equation that we're going to roll with. So what I'm going to do is that I'm going to set up the two parts that we're going to need. We want to know what was the value of the car in April 2009 and what is going to be the predicted value of the car in April 2018, assuming that we're going to keep losing this particular percentage per year. So to do that, I'm going to set these up over here on the left-hand side, and I'll show you why these are. Okay, so for the first one, we have 2009, okay? And so what we're going to do is home in on how many years we started in 2004, okay? And so it looks like how many years passed to get to 2009? Well, the answer is going to be 5, right? So that is going to be our first thing that we're going to put in the calculator, and that's going to give us the value in April 2009 of the car that Sanjina purchased. So punching that in, we get, looks like $9,424.96. Okay, and so that's how much it was worth in April 2009. Now, what is going to be the predicted value, okay, in the April 2018? Okay, so they're probably in this problem in 2012, and how many years is it going to be from this business of 2004? So the difference between 2004 and 2018 is going to be 14 years. And so I'm going to put 14 right here and punch it into the calculator to get this amount, $2,432.93. Now for both of those, again, I round to the nearest cent because that's just the way that we talk about money and whatnot if we were going for the purchasing prices. Okay, so that's basically the way that we roll for this business of again, looking at a scenario, finding what we need. In this one, we needed a rate. Sometimes we need an old amount. Sometimes we need a new amount, etc., etc. And if it's over a certain amount of years or a certain amount of time period, then we got to go ahead and break it down into a single unit time period to build a brand new equation with. Okay, and so that's how you do that. And yeah, good luck with the exercises that follow. So thanks for watching.